Hello everyone. Now let's move on to the next question, question number 6a. So our first question here, it says 8 books are to be arranged on a shelf. There are 4 mathematic books, 3 geographic books, and 1 French book. So immediately I'm going to write it down. So 1 mathematic, alright, M is equals to 1, G is equals to 3, and F is equals to 1. Sorry, this is 4, yeah? Okay. Now, first part. You want to find the number of different arrangements of the books if there are no restrictions. Okay, so how many are there in total? Since there are no restrictions, it's going to be 4 plus 3, that's 7, and 8, right? So you have 8 in total. Since there are no restrictions, we're just going to deal with 8 factorial. And that is going to give us 40,320. Now, note that we are not going to divide this by 4 factorial or 3 factorial because these are books. Not all books are the same. The only time that we're going to divide this is when we have either blank spaces, numbers, or letters. Okay, those are duplicates that we can divide. Now, moving on to the next part, we want to find the number of different arrangements if mathematic books have to be kept together. Okay. Let's write this down. We have 8 in total. You want to make sure mathematics are being kept together. 1, 2, 3, 4. And then 1, 2, 3, and 4. So the rest of the remaining 4 slots here is going to be the geography and the French book. So if I want to keep the mathematic books together, I'm going to consider this as one group. So this will move as 1. That's 1, 2, 3, 4, 5. So I'm going to write down as 5 factorial. Okay. So the reason that we're going to move this as a group is that this mathematics can be in the second, third, fourth, and fifth, and so on. But this is not the end. We need to multiply this with 4 factorial. Why? Because since the mathematic books are not unique, we need to move them inside the group as well. Okay, hence the 4 factorial. Then our answer is going to be 2880. On to the next part, we have part 3. So part 3, the question says that find the number of different arrangements if mathematic books have to be kept together and the geography books have to be kept together. Okay, previously it was just mathematic books. Now it's also geographic books. So mathematics 1, 2, 3, and 4, same method. But now we have geographic books 1, 2, 3, and then our French book, which is empty. So let's make sure we put these two into a group. Now there's only 1, 2, and 3 slots, so that's going to be 3 factorial. Make sure you move the books inside of the group, so that's times 4 factorials for the mathematics and times 3 factorial for the geography books. And finally, our final answer is going to be 864. Okay, let me finalize everything here. All right, great. So now let's move on to part B. So in part B, it says a team of 6 players is to be chosen from 8 men and 4 women. So we want to choose, right? So choose 6. We have 8 men, 4 women. Find the number of different ways this can be done if there are no restrictions. Number of different ways. So when the question tells you it's a number of different ways, not arrangements, we're going to use combination, NCR, right? So we have a total of 12 people here, and since there's no restriction, we don't care whether there's all men, all women, or how many men or how many women are there going to be in a team. So out of 12, we're going to pick 6, and that is going to give us 924. Yeah. So our next question, our next question is going to be, there is at least 1 woman in the team. Okay, now at least 1 woman. So we have 6, right? 6 players you want to choose. So we start with 1 woman and the rest are going to be men. 1, 2, 3, 4, 5. Then we move on to 2 women. 1, 2, 3, 4. 3 women. 1, 2, 3. 4 women. 1, 2, 5. I don't think we have 5. Yeah. So we only stop at 4 women. Okay. Now, using this, we're going to find each of their respective different ways. Now, for 1 woman, we only want to get 1 woman out of the 4. So that's going to be 4, choose 1, times the men. We have 8 men, and you want to choose 5. So 8C5. And for the second one, we have 2 women. So that's 4C 4C2 times 8C4 for 4 men. And then the 3 women is 4C3 times 8C3. Then the last one is 4C4 times 8C2. Okay. Now plugging everything into our calculator, the first one will have 224, and the second one we have 420. The third one we have 224, and the last one we have 28. Okay, since we're dealing with different events here, so we are going to add everything together. We'll finalize that answer. We have 224 plus 420 plus 224 plus 28, and we'll have 896 ways. Okay.